the mic?
It's right there. If it's working.
If it's working. Hello? That's not a switch. It'd be really nice if we had an AV guy. Because that's...
Do you see a switch? No. Really? Does that one work?
I hope so. Our first... Can anybody hear me? Okay, good. Our first talk this afternoon here will be using Grok to walk like a duck by Mr. Brandon Rhodes.
Well, hey everyone. The first words I planned to say were I'm Brandon Rhodes and read the title of my talk, but that's superfluous now, so let's move into it. Many programming languages, as many of you have doubtless encountered, use static typing. The C language that you've seen if you've ever looked under Python's hood is famous for this. Simple, what? Is this better? Yeah. All right. Many programming languages use static typing. If you've ever looked under Python's hood and found the C language, you've seen that functions look something like this. They have to set, they promise to only accept one kind of argument and promise to only return one kind of return value, and they're stuck. They can't ever do anything else. Python typing, of course, is dynamic. The same function in Python says nothing about the kind of the argument or the return value. It just has to be something that's willing to be divided by 2. You don't, in Python, worry about whether an object is of the right type. You simply try using it. This is called duck typing, and because you ask, well, does it walk like a duck? Does it quack like a duck? Then it's a duck. Or, in the case of our example, is it willing to be divided by 2? Well, then it's numberish enough for us. Are you guys able to hear? Yes. I'm not holding it too close? All right. So now imagine that you've gotten hold of a wonderful duck processing library to which you want to pass an object. But the object that you want to pass isn't a duck. What if it doesn't already quack? What if it bears not the least resemblance to a duck? And I'm going to use a concrete example. Imagine that you have a message object from the Python email module. These things are great. I didn't know about them until recently. There's an email module from which you can have it read an email message, and rather than giving you a dictionary of data or a list, it actually gives you a live object that you can query and find out everything about the email message, including if it's multi-part. Remember, my messages can have several parts, and what the types of the parts are. My messages are recursive. You can have multi-part messages inside of which are more multi-part messages, etc. So we might come up with the idea of writing, say, in Python a GUI email client, where we want to display a message in what's called a tree widget. That's the thing over on the left there. You've seen them lots of times before. There are hierarchies you need to break down. This is a single email message. This isn't several. This isn't your mailbox. These are the only parts of a single message, and we're imagining that maybe the user will want to click through them and look at them. We're going to imagine an imaginary tree widget that says, I'm willing to display any tree hierarchy you can provide me, as long as the nodes in the tree, that is, as long as the object you pass has 3 methods: a name that I can display, children, which should fetch more objects of the same type that live under this part of the tree, and then a length so that I can do layout planning without the expense of fetching all your children when I first come up. How can we add these behaviors to a message object? That is, how can we make an object which is not a duck behave like a duck? Any of you guys who were around in the early heady days of OO remember back when professors told us that subclassing would be the way we solved every problem. We would create a tree message class that inherits from the normal message class. Up there at the top, it inherits from message, so it's going to get all the abilities of a message, but we're going to add to it those 3 extra methods that it's going to need if it's going to be successfully handed off to that tree widget. What will the test suite look like? And I'm bringing up the test suite, by the way, because the ability to test things is crucial to your design. If you have a pretty application design that's hard to test, it's broken because untested code is broken code. So let's see what testing a subclass looks like. Well, your test suite is going to have to instantiate a tree message, one of these new classes, and verify its tree-like behavior. So for instance, here's a working test class. It gets the text of an email, instantiates it as a message, but as a tree message, and then sees that it has the three methods that we added. Now, that only worked because we were lucky. Because our test can cheaply instantiate messages. Here, using some cheap yellow highlighter, I've highlighted the fact that a text string is all we need to create a message. So it was really, really easy to stick it into a unit test. But what if we did this subclass in, say, an LDAP library, or an object that backed into the database? What if we did something that was expensive to set up and create? We probably couldn't have had unit tests. We would have had to have end-to-end functional tests as the only way to see if our three tiny little functions even worked. There's a second way that we were lucky, which is that the message from string method that we called in from the email module to create messages for us will take a second optional argument that we use here, called a factory argument. Now this is really neat. Basically it says this: normally I create messages and return messages to you. But if you want some other kind of object created instead, just pass this class to me as the second argument, and I'll create some of those instead. And so then our test can go on to test it. But this is completely dependent on the fact that we were lucky enough to use something in the standard library, and they tend to use factory arguments so that you can override what they return to you. But what if you're using some other guy's INET module, you're on your deadline, you don't have time to rewrite it, and it just returns messages? Doesn't ask you. What if you're using a module that stores messages in a database, and it won't return anything but messages? Not only can, of course, you not then run useful tests, you just can't use the subclass you're creating. This is a huge problem in big object systems, where if the person has forgotten to give you a way to ask for a different type of object, you can't even get your subclasses created. Finally, please note that we have just completely broken the message class's behavior. It turns out that len is already defined on a message. Len is the total number of headers in the message. This means that a native Python message, which says I have 3 headers, behaves quite differently from our tree message, which says I have 0 subparts. I'm not enough multi-part message. This means that if we get this message that works so well with our tree widget and hand it to anybody else, it's going to completely break. Look, it's going to partially break because this one method won't work. But what if some of the message's internal methods ask for its own length to get something done? I mean, the amount of breakage that can occur here is from a medium to a huge amount, and it's because subclassing isn't a general solution. It only works if you're trying to pass the object into an environment which doesn't need anything of the same name as what the object's already got. So how does subclassing score? It has the good feature that it does no harm to normal messages. If there's parts of the big, web framework you and your friends are writing that just need to create those normal messages, they won't look any different because we've written a subclass. But you cannot do tests in isolation from the base class, as we've seen. If you're ever going to get instances of your subclass, you need control of all of the factories that might return you messages in your framework. It breaks if names collide. And so with 3 strikes against it, I'm going to give subclassing a D. It's not a complete failure, but it's not a general solution you can count on working unless the stars just happen to align right. The second thing I'm going to mention briefly is using a mix-in. The goal of this is exactly the same, winding up with a subclass. The difference is that you put the functions not in the ultimate tree message class, but you put them in something that you're just called mix-in, that lets the functions stand alone, separate from the base class, and then they all get pulled together through multiple inheritance. This makes the test suite look really pretty because, of course, the functions in mix-in don't really know if they're part of the message or not. They just care if they're part of an object that can offer a get content type and is multi-part and so on method. So in your test suite, you can pull in the mix-in, you see it mentioned up there at the top, into a class that provides dummy values of what could be these very expensive operations inside of the base class, and perform a basic unit test that shows you whether you're returning the right values. Now, of course, yes, you want functional tests that go set up a database or set up an OLAP server and do an end-to-end test. But gosh gosh, it's nice to just have unit tests that don't have to instantiate the base class if they don't have to. A mixin, of course, once again, because it's using subclassing, does no harm to the base class. We can now test the mixin by itself in isolation from the base class, but we still need control of all the factories in the app if we're going to get tree messages rather than messages returned to us. Still, we haven't solved the problem of names colliding, that we're overriding the length method. So with only 2 strikes against it, I'll give a mixin a C. Now, it is only because of completeness that I am going to mention monkey patching. Monkey patching is a bad habit in all but 1 or 2 extremely specialized cases that I won't go into. To monkey patch a class, you add or change its methods dynamically. Doing it well is a bit more verbose than this, and therefore wider than the slide, but it looks something like this. You just declare your 3 functions, and then you go into the message class itself after it's been loaded from disk out of the Py file and Python that defines it, and you actually overwrite its methods with these new ones. You destroy its old functionality to provide the new. Is this at all desirable? Well, golly! We don't need a factory. For the first time in any of these methods we've looked at, we don't care if our IMAP library and everybody else just returns as plain messages, because, well, darned if we haven't ruined plain messages by making them do what we need. But, enough about the advantages of monkey patching. Let's look at some of the detractions. You've changed the class itself. If elsewhere in your big application or framework there are people that need to create and delete messages, well, maybe they'll be sensitive to the changes you've made. Maybe they'll see them and maybe they'll not. We're still broken. We're still having to overwrite one length method with another, and we haven't solved how we're going to get these guys working with people that just need normal messages. Okay, this is not a general solution because you can pretty much only do it once, because if 2 people try to provide a main method to the message for different reasons, they're going to overwrite each other's changes. Remember, Ruby people are excited because their language is prettier than Perl. With 4 strikes against it, I and all other responsible Python programmers I know of give monkey patching for this purpose, for the purpose of specializing a class, an F. So all of that is set up so that we can now discuss adapters, a bulletproof industrial strength design pattern, first widely touted, as far as I know, in the famous Gang of 4 design patterns book back in '94. I don't know any Java programmers without this on their shelf, because this book is fundamental to planning a big application and thinking about the ways that you can get classes to talk together. They introduced the idea that they call an adapter by describing the idea of just giving up trying to make a message do things that it doesn't want to. Just give it up. Create an entirely new kind of object that has no relationship to a message, except that when you call its methods, it can turn around and ask a message for that information. An implementation of an adapter looks just like this. It inherits from object because, again, it has no class relationship to a message, but it takes a message in its init method. Again, this is the first thing we've seen today with an init message, because this is the first thing that's just supposed to operate standalone. All right, so it's sort of like a baseball catcher. Its init function is ready to take a message and hide it behind its back. And then, when you call the functions that it supports, it very cleverly looks behind its back and looks at the properties of the message, and then turns around and gives the correct responses. But it completely hides from the tree widget that just needs these messages any of the message, any of these methods, any of the message-like properties of the class. So how does rapid booking your code, instead of passing the message to the tree widget, as you would have done in all the previous examples, you get the message, wrap it up in the message tree adapter, and then pass it to the tree widget. Your test suite can, of course, try adapting a mock-up object, because you saw that code a second ago. It made no tests to see if it was actually a message that was passed to it. It just called it that. So if messages are very expensive to construct or require other servers to be running a basic unit test, you just create a fake message. It just returns constant values, and then wrap the adapter around it to see if you get the right results. So the adapter design pattern, once again, like the first two things we looked at, subclassing, does no harm to the base class. Like a mix-in, you can test it against a mock-up rather than the actual base class. Like monkey patching, you don't need to grab control of all of the factories in your framework that are giving you messages to display. It's okay if they're normal messages because the adapter is built to grab and use a normal message. And for the first time, we have escaped the problem that a length on a tree node and a length on a message are different concepts because the adapter has created, I'll say it this way, it's created a separate namespace in which its methods live that's just completely separate from the namespace of the class that's being adapted. The only problem, of course, is that wrapping is somewhat annoying. You've got to remember every time you pass something, is this someone that can handle a normal message, or is this someone that I've got to adapt it for? We'll look at that in a second. But with only one strike against it, I'm going to give the old-fashioned adapter design pattern a solid B grade. Now, why would I call wrapping annoying? My example made it look so easy. I just got the message, adapted it, and passed it to the tree widget. Well, it is easy. You've only got to do it once. But in a real application, it's going to happen all through your code. You're going to look through your code, and if it's an application of any complexity, you're all the time going to be grabbing one adapter and sending an object off, grabbing another adapter for the same object, sometimes having to remember to send the object off there. And if you look, all of this knowledge about your consumers of objects over right, and all of the knowledge about what your adapters do is getting scattered through all of your code. How can you avoid repeating yourself and scattering information about adapters and I'm calling them the customers, the people, things like the tree widget that need this object passed to it? How can you avoid scattering that information everywhere? Well, the key is to hone in on this one statement, think about it for a second, and seeing that it conflates two completely separate issues. Why does this line work? It works because a tree widget needs what our adapter provides. But this line of code keeps that information hidden inside of our head. If we think it's our job to go through our code writing this every time some consumer of an object needs something different, that information is just staying up in our head. The framework, PyCon, doesn't know that. We need some way to define what the tree widget needs that the adapter provides so they can get hooked up. Again, in design patterns, they call this idea an interface. It actually first became a first-class object in the language with Module 3 8 years earlier. Java adopted Module 3's type system pretty much unchanged, so interfaces exist there as well. And the main way that I use them in Python is with Zope. For the moment, forget anything you might have experienced before, good or otherwise, about Zope, the web framework. We're just going to be talking about the component framework, which is in two classes, two packages, Zope.interface and Zope.component, with 3 simple steps. Zope will rid your code of all that manual adaptation. All you have to do is define an interface that is a name for that capability that the tree widget needs. Register your adapter as, hey, I can grab a message and make it do that. And then the consumer has to request adaptation. That first step, defining, looks just like this. This is running Python code. You import interface, create what looks like a class inheriting from it, but it gets a different meta class, so it's really a quite different object called an interface. And you describe the way that you're planning on calling the methods, you leave self out, the way that you're actually planning on calling the methods of the classes that provide an iTree. And following the venerable gang before, we typically put a capital I at the beginning of the names of interfaces, because they found otherwise you get confused as tar about which of your classes are classes and which objects are interfaces. Second, This is the simplest way I know of to register an adapter in Zope, Zope component, and then you just say provide adapter, describe it. And then the consumer needs to request that its argument be adapted to iTree by calling iTree like a function. Now you might say, wait a minute, that looks hideous. Calling an interface like a function, that's weird. But in fact, it's not. It's very Pythonic. You're used to calling types in order to get things converted into them. You call in list and float if you want things turned into those types. Similarly here, you're calling iTree in exactly the same way to get something that obeys that interface. And that's it. With those 3 steps, and I'll give you a link at the end with a link to working code. With this simple 3 steps, the adaptation happens automatically. Adaptation fixes that last problem of you having to remember when to adapt. And what does it do? If you step back and look at your application, what it does is it pulls out of your application all that information you were scattering through it about what adapters provide and what consumers need, and that information gets absorbed out into those layers themselves and leaves your application. I'm going to conclude now with 3 quick practical tips and 3 exciting closing statements. Because I'm giving practical tips because I want you to go on and try this. I mean, those of you who use Python through slow command line tools, if you need adaptation, do it manually because it'll probably just happen once in a little command line interface. But if you do big web apps, if you do big GUI apps, if you do a lot of middleware like I do, I want you to go home and try this, so I'm going to give you some practical advice. First, you can provide a default argument for adaptation. This is useful because can you guess what iTree does if it doesn't know how to adapt arg? It throws an exception, just like trying to look up something in a dictionary that's not there. Now, what if that annoys you? What if you go home and you think, oh, I have this class I was about to add, and sure enough, I need to adapt it. Let me try that thing Brandon talked about in PyCon. But what if there are already 30 objects that already work? They will now all get exceptions raised because you haven't written adapters for them. So, if you're in that situation where 30 objects already work with the tree widget, you just want to play with it with adaptations for that one extra one, well, as usual, there's a right way out. And then there's an easy way out. The right way is to actually use Zope to actually tell Zope that all of your other things that were already working with the tree widget, in fact, support iTree. Then, just like int and float will pass an int and float back to you unchanged if you call them on it, in the exact same way, iTree arg will return to you the argument unchanged. A no-op. It doesn't rewrap it in a null wrapper or anything, it just comes back. The fast way is just to add a second argument, because just like the get operation you're used to using on the dict, we'll take an optional second argument about what you want instead of key error if they're used not in the dictionary. Just like getter has an optional last argument you can get it to say what you want back instead of an attribute error if name is not in this object. Similarly, calling iTree with arg and then arg again means you'll just get arg back unchanged as a default if it's not able to adapt. Practical tip number 2, your adapter can announce what it adapts. I showed you code like this. The adapter looks really simple, and then when I call provide adapter, I state what it adapts and provides. Zope actually lets you just call those as functions up in the class, and it'll auto-detect that they were called right there. And I find that easier to read code because I find out what the adapter's for when I'm reading it, rather than when I go read the registration code. Finally, there's actually 3 ways to register. The way I showed you just now, calling provide adapter, Zope people, for some reason, don't generally use that a lot. I use it some, but they actually only use that in unit tests. If you think like Jim Fulton, you use XML. And so for all of the information you put in the adapter, you have to turn around and repeat yourself by doing a bit of XML. They do this in Java land, so maybe he thought it was a good idea. I have been doing a lot of web work recently, and this is where we get into Grok. Grok is a Ruby on Rails-like auto-configuration layer for Zope. So that instead of having to write a bunch of classes and then write a bunch of XML to hook it all together, you simply write your classes using some simple conventions like naming page templates the same as the class that runs them. And Grok will auto-detect your entire application and hook it all together using the default rules. which you can override for cases where they don't make sense, but it means that reasonable configuration, normal stuff, completely disappears from your application, and even the specialized stuff you do winds up in your Python code and not in XML. All right, now at my closing statements. Following on from that, I'm going to say that Grok is cool. I've been using it for a while now to do XML-RPC middleware, and it's incredible to be able to get a neat web widget I want to use, to get some code that other people have written, and get them put together just by writing the middleware and not touching the original classes themselves. Grok lets you define view adapters that prep your objects for the web. Grok is a framework, Rhodes is a framework, that basically gets an incoming web request, finds the objects it refers to, and then tries to adapt them so they're displayable on the screen. Your job is not to harm the classes you're mapping, which can be from anything, SQL Alchemy, Storm, CODB, an IMAP directory, whatever. They can come from anywhere because you don't harm them, you don't touch them, you don't try to subclass them. You just write a thin layer of easily testable views to get them out where the customers can see them. Grok lets you create, in other words, I think of it as spacesuits, so that your object can survive out on the web. It provides all of the armor and protection so that your objects can be seen and can be manipulated. Closing statement number 2. Dynamic adaptation might feel like a type declaration. You might have looked at this earlier and said, wait a minute, that looks like C. I'm talking about what kind of object I want. This is terrible. No, it's not. I can't make the longer argument right now, but it's specifying a behavior, not a type. It's dynamic, as we've seen, and it's optional because you can provide that second argument so that it only gets used when you have provided an adapter. Think of adapters as two-story attributes. Do you guys remember how exciting it was when PyCon gave packages, where instead of modules being in a flat namespace, you could now have, a foo module under one package and a foo module under another? How exciting it was to have two levels there? Well, you can think about an adapter if you went all the way and always adapted arguments before using them, which I generally only do with stuff coming in from elsewhere. So code internal to my library will just use the object's path. It's only when I face the user that I declare an interface and give them the chance to provide an adapter before I touch their object. But if you were to go all the way and use it everywhere, you essentially are creating two-story or fully qualified method and attribute names, just like packages provided an extra level for us. My final statement is that I think, okay, let's say that I have found the work I do creating mix-ups and mashups and getting lots of classes other people have written and getting them quickly up and running on the web. I believe that this is the future. From good OO people I have talked to, this is exciting. They're not doing this in Java. As far as I know, they're not doing it in Ruby. This is a fully bulletproof, strong step forward from the old way of doing OO that usefully moves all sorts of crud out of your application and into the definition of your adapters where it belongs. And darn if it isn't exciting. You all, if you want, have the opportunity to sprint with me. I mentioned that neat auto configuration Grok does only works right now in the Grok web framework. So only if you pay the expense of the whole framework can you use it. I'm going to be hosting a sprint starting, I guess it's tomorrow afternoon. There's the organizational meeting where we are going to get that capability inside of Grok and break it out into a separate package where any Zope user can get that free, fun auto configuration so that, don't tell Jim Fulton, but we can start taking that XML out of Zope. Go to this link where I've put example working source code of all of the examples I gave here, and where I'm going to keep putting more information as I get questions from you guys about adapters. Thank you very much. Out of time? We have about 2 minutes for questions. Did I confuse anyone? Go ahead.
Yeah, you were going to do some work on having the standalone. Is there any plans for turning this into a general standalone facility that's completely under like doing web-like that's for just general use, only programs?
The code that I showed today, except for the Grok auto. Oh, thank you. Oh, I hate speakers when they don't do that. And I thought, I
I'm not going to do that when I grow up and be a speaker. The question was, is there a way to use this outside of the Zope web framework? And the answer is that Zope.component and Zope.interface are kind of standalone. If you import those into your application, if you install them or whatever, they don't call it the rest of Zope. They are a standalone component framework. So again, if you go to this URL, you will find working code that when you build it out, grabs those two modules and works. And does dynamically registered adapters within a few seconds if you're installing it on the machine. It's only the auto configuration part, that third three ways to configure that I did, only that is right now trapped in the web framework. All the rest of it is already broken out. More questions? Thanks. Yes? Multi-adapters are awesome. Perhaps I can speak on them next year. But yes, the Zope component framework provides several other fundamental design patterns besides unitary adapters like I did here. There are multi-adapters, which you get three things and give you an interface. There are utilities, which adapt nothing. It's a cool idea that sounds weird. And I only wish I had